Hello everyone, welcome to the Hilarious Classes channel. This is Praveen Kumar. In the previous video I discussed about what is meant by cement and what are the different manufacturing methods, and while manufacturing the cement what are the different compounds are being formed, what are the different bulk compounds are being formed while preparing the cement, and similarly what are the different properties of those four components of bulk compounds, and these are being discussed in the previous video. And the last continued part is hydration part and how that CSH gel has been formed, and that will be continued in this video. So hydration of cement. So before adding a little bit amount of water to the cement, if we add cement aggregates together in a well mannered mixture, it won't get binded and it is existed like a abstract formation only while adding some little bit amount of water, then only it will be get absorbed and it will be transferred into a solid formation. So likewise anhydrous cement won't get binded with the coarse aggregates, only with the help of while adding a little bit amount of water only it will be gets binded, because there is a chemical reaction has been taken place between the cement and water, and then only it will get binded into a solid formation. And similarly anhydrous cement compounds when mixed with water react with each other to form hydrated compounds of very low solubility. The hydration of cement can be visualized in two ways, and the two ways will be continued either in liquid formation or in solid formation, and these are the general two ways of hydrated cement that we can able to visualize and how it will behave for the reaction in between, and we can able to observe that reaction between the cement as well as aggregates. The first is through solution mechanism. In the cement, compounds dissolve to produce a supersaturated solution from which different hydrated products get participated. So which means through the solution there is a reaction between the cement as well as some dissolved products will get participated in this chemical reaction. And the second way of mechanism is, the second possibility is that water attacks cement compounds in the solid state, converting the compounds into hydrated products starting from the surface and proceeding to the interior of the compounds with time. Which means in the second possible way is whenever the water reacts with the solid components, so then the hydrated components will start from the outer surface and then slowly it will reach to the interior part. So if we observe the graphical representation between the rate of liberation versus the heat liberation from a setting time in hours, that we can able to observe, if we add a little bit amount of water to the amorphous or unhydrated cement, initially the rate of liberation is somewhat more, and then with increase in the time slowly it will be reduced, and then after again whenever that hydration process has been started, our second stage of hydration, which means the solid states are getting started from the outer surface to the internal surfaces, somewhat the rate of liberation is more, and again the rate of liberation will be reduced. So this is the hydration part. So next one, heat of hydration. Hydration of cement is different, heat of hydration is different. So heat of hydration is whenever the cement reacts with the water, there is a little bit amount of heat will be released. So that heat is an exothermic reaction. The reaction liberates considers a quantity of heat. This liberates of heat is the heat of hydration. On mixing cement with the water, a rapid heat evolution lasting a few minutes occurs. This heat evolution is probably due to the reaction of solution of aluminates and sulfides. So only because of the existence of aluminates and sulfides, the heat will be released a little bit amount of more whenever these aluminates and sulfides are more. So to evolve or to reduce that heat liberation, we can able to reduce that aluminates and sulfides in that particular cement. So definitely we can able to reduce the heat liberation also. So this initial heat evolution causes quickly when the solubility of aluminate is depressed by gypsum. After release of some amount of heat, the next stage of evolution of heat, that is because of the reaction between that C3S and the water. So tricalcium silicates are also responsible for the release of some amount of heat while it reacts with the water. So this is how the heat is released whenever the water is going to added to the anhydrous cement. So that is the heat of hydration of exothermic. So next, while coming to the different compounds hydrates at different rates and liberate different quantity of heat. So in our Bohr compounds, basically we are having four kind of things that we can able to observe, that is C2S, C3S and C3A, C4AF. So each and every compound having certain limits of heat will be released. So if we observe this graph and fraction hydrated with respect to the time log scale in days, if we observe the rate of hydration of pure compounds, so which means the hydration is somewhat less for tricalcium silicate and dicalcium silicates, and there is a rapid increase in the heat for tricalcium aluminate and tetracalcium aluminoferrates, and fraction heated from a little bit more for those three particular things, but actually the maximum amount of volume is occupied with tricalcium silicate and dicalcium silicates only. If we observe here, heat of hydration at the time with respect to the ages, tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrates, and these are different stages of heat of hydration at the time in calories per gram in 3 days, 90 days variation and for 13 years of variation. So this is how the heat is released that we can able to observe from both compounds. So the basic things of maximum percentage occupied with calcium silicate and hydration. The maximum amount of volume will be occupied with tricalcium dicalcium silicates whenever that calcium silicates reacts with a little bit amount of water or a maximum amount of water. The tricalcium and dicalcium silicates forms into CSH gel, which is calcium silicates and hydrates gel, which is more responsible for the strengthening or bonding of concrete, and as well as calcium hydroxide also been formed. So it makes up to 50 to 60% of the volume of solids in a completely hydrated cement paste. The fact that the term CSH is hyphenated signifies that CSH is not a well-defined compound. The morphology of CSH shows a poorly crystalline fibrous mass, which means that CSH gel that we can able to observe in morphology, that we can able to see in a fibrous form of formation, and that is more responsible for the bonding between the cementitious materials. And similarly, calcium hydroxide is also one of the basic compound, while that tricalcium and dicalcium silicates reacts with that particular water. The other products of hydrates of C3S, C2S in calcium hydroxide, in contrast to CSH gel, the calcium hydroxide in a compound with a distinctive hexagonal prism morphology, it constitutes 20 to 25% of the volume of solids in the hydrated paste. The lack of duration of concrete is on account of the presence of calcium hydroxide. So calcium hydroxide is also more responsible for durability. Whenever the calcium hydroxide is very less in the formation of concrete, the durability is also somewhat reduced. Durability means the lifespan of the concrete. So the next one is calcium aluminates. Whenever it reacts with the water, again there are some little bit amount of formations have been developed, which means tricalcium aluminate or tetracalcium aluminoferrates. Whenever these things are reacts with the water which is added to the cement, the hydration of that particular aluminates has been subjected to numerous investigations, but there is still some uncertainty about some of the reported products due to the hydration of C3A, a calcium aluminate system, CaO, and calcium, as well as these things have been formed. So while if we observe in a graphical representation with respect to the compressive strength and age, the more responsible things are C3S and C2S, and that C3 and C4AF is somewhat less responsible for getting the strength the earlier stages or for the longer span also. And while coming to the structure of hydrated cement, whenever if we add a little bit amount of water or the maximum amount of water to the cement, we can observe some structure, and among these structures the basic thing is transition zone. If we add a little bit amount of water, and cement sand will be forming like a paste, and this paste will be inserted between the voids of coarser particles, and if it is converted into a solid form, there is a zone between that solid parts as well as cement paste, and that zone we can simply call it as transition zone. If we observe the structure of cement particles whenever there is a water has been added, if we add more water to the cement, here we can get whenever the water is evaporated, then the voids formation will be more. If we use a very little bit amount of water, then even after evaporation also we may get a little bit amount of voids only. So whenever if we use a little bit amount of water only, then only we can get a proper way of structure and strength to the concrete or to the cement paste. So in the next class we will discuss about what are the tests are to be conducted over cement and their properties. Thank you.